Earlier this year, I helped out the BBC filming at a company called Firefly in Texas, who manufacture rockets, engines, and lunar landers. This was specifically a test fire of their Reaver engine, and I was fascinated to get an up-close, slow-mo look of a test fire. Every test fire uses a lot of resources and can't easily be repeated, so we had one attempt at this today. Because of that, I spent a lot of time talking to some of the engineers that work there to try and figure out the best position for the camera, best way to protect the camera, and best way to trigger the camera, because obviously it couldn't be anywhere near this thing when it fired. But thankfully they had a housing large enough to cram the camera in. The area around the camera would be subjected to intense heat and vibration, so we made sure to seal the camera in there as much as possible and then protect the cables coming out the back of the box. When filming a one-off event like this rocket test fire, or for example a huge explosion, I always find it useful to ask as many people as possible how bright they think the explosion or fire will be. And that's actually quite a difficult thing to quantify or put into words. What I wanted to see was detail in the flame, but without making everything else in the image completely black. So I was trying to find a nice middle ground. After all my settings were in, we had to clear the area about an hour before the test fire. But thankfully the test fire was a success. The camera triggered at the perfect moment. And here's our lovely slow-mo footage. Here we go. The white cloud you see here is oxygen, one of the two propellants. This is done to condition the liquid oxygen to ensure that it's at the desired temperature and density. The propellants being used here are liquid oxygen and RP1, which stands for rocket propellant 1. Very common fuel in liquid rocket engines. It's basically a highly refined kerosene, more so than typical jet fuel. The green flame shooting out is triethylaminium triethyboron, also pronounced TTEB. It's a fluid that combusts when it comes into contact with oxygen/air. I love the fact that this initial puff of flame is lingering in the air, because it's a great medium to see the shock waves caused by the engine ramping up. As the thrust is increasing, you can now see Mac diamonds appearing in the exhaust. The supersonic flow of exhaust gas and the shape of the nozzle essentially causes standing shockwaves that appear in this diamond formation. The orange flame is an indication that the combustion has started between the main propellants. As the power ramps up, the RP1 and liquid oxygen burn so bright that you actually aren't able to see the Mac diamonds as well, but they are there for the entire duration of this. One of the unique things about Firefly is they use a tap-off engine cycle, which eliminates the need for additional combustion parts, which makes it more reliable, lighter, and cheaper to produce. Now at full power, if this was in a vacuum, the engine would be generating 45,000 pounds of thrust. The temperature of this combustion is close to 5,500 degrees Fahrenheit, or around 3,040 degrees Celsius. The fact that I underexposed the scene so much that it effectively looks like nighttime, and the flame is still blown out, gives a great indication of just how bright this actually is. This Reaver engine uses a turbo pump. The job of the turbo pump is to take the stored low-pressure propellants and then massively increase the pressure before sending them to the main combustion chamber. This increases the thrust and efficiency of the engine. I think the most insane thing to me about this footage is that you could look at this and not necessarily know this was at 2,000 frames a second. This is 80 times slower than real time, and the only indication is when these little pieces of debris are flying past the camera. The flame and the vibrations produced by the engine look so incredibly fast it could almost be real time. All in all, it was a pretty nerve-wracking experience, but I'm really excited about the footage we got. I want to give a big thanks to Firefly for letting me have such great close-up access to this test fire, and also providing me with all the information about what's happening in the slow-mo footage. Hopefully you enjoyed this video. Let me know if you'd like to see more rocket-themed videos in the future, and thank you very much for watching.